Good morning, children. Continuation of the increasing and decreasing function. How to find the intervals? Take down the heading. Find the intervals. Find the intervals in which the following functions are strictly increasing or decreasing. Strictly increasing or decreasing. First one, just take down the heading. Find the intervals in which the following functions are strictly increasing or decreasing. First question in that. First one. First question. X square plus 2x minus 5. X square plus 2x minus 5. Take the given question as f of x. F of x is equal to x square plus 2x minus 5. You differentiate it with respect to the x. So f dash of x is equal to what? 2x plus 2. So f dash of x is equal to 0. So 2x plus 2 is equal to 0. 2x is equal to minus 2. X is equal to minus 1. X equals minus 1. We got it as minus 1. So next step. So where does the minus 1 lies? The minus 1 lies between minus infinity to plus infinity. Isn't it? Minus infinity to plus infinity. Let us take one value in between this. Let us take minus 2. If you take minus 1, after minus 1 you can give minus 2, minus 3, minus 4, so on. Assume that you are taking one negative number here. Let x is equal to some minus 2. We will get it as f dash of x is equal to minus 2 plus 2, which is equal to what? Minus 4 plus 2 is equal to negative. We are getting negative. Next, let x is equal to plus 1 I will take. So f dash is equal to 2 into 1 plus 2, which is equal to what? 4, which is equal to what? Positive. So here it is increasing function, from here it is decreasing function, isn't it? So how to give the conclusion? So we will give the conclusion that f is strictly, since, write the condition that since, just a minute, we will give the conclusion that since f dash of x is greater than 0, hence f is strictly increasing at minus 1 to infinity. Since f dash of x is less than 0, hence f is strictly decreasing at minus infinity to minus 1. So here the intervals are, what are the intervals? The intervals are minus 1 to plus infinity for increasing, minus 1 minus infinity to minus 1 for decreasing function. Is it clear? Next, for the decreasing function. Next, take the second one. Second question. Minus 2x cube minus 9x square minus 12x plus 1. Let us take the question. Minus 2x cube minus 9x square minus 12x plus 1. So how to solve it? Take the given question as f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. You differentiate the equation with respect to x. F dash of x is equal to what? Minus 3 2s are 6x square minus 9 2s are 18x minus 12. Take out the minus 6 as common. So the left term is x square plus 3x plus 2, which is equal to minus 6x square plus 2x plus 1x plus 2. Factorize it. Minus 6 into, take out the x common, x plus 2 plus 1 as common, x plus 2. So what are the factors then? X plus 2 into x plus 1 are the factors. It means that if you take f dash of x is equal to 0, you will get 6 into x plus 2 into x plus 1 is equal to 0. So x plus 2 is equal to 0, x is equal to minus 2, x plus 1 is equal to 0, x is equal to minus 1. So what are the intervals then? Just I hope you have copied it. Okay. Next step. Minus 2 and minus 1. We got the intervals as minus 2 and minus 1. So what is the next step then? It lies between minus 2, minus 1, plus infinity and minus infinity, isn't it? Then how to divide? Take the number in between these two and these two. We have to check whether they are increasing and decreasing. Here there exist the 4 intervals, isn't it? Which are the 4 intervals? Minus infinity to minus 2, minus 2 to minus, 3 intervals. Minus infinity to minus 2, minus 2 to minus 1, minus 1 to infinity. Let us take the box. First one are the intervals. First one is intervals. Second one is sign. Next is nature of the function. It is a sign of f dash of x. What is the first one? From minus infinity to minus 2, you check out. So what you will get? So we took minus 6 as common, isn't it? Minus, first term is minus, here the term is minus 6 into the roots are x plus 1 into x plus 2. If you give the x as the negative term, that is minus 3, here you will get negative. If you take minus 3, here also you will get negative. So negative. So if all the 3 terms are negative, so f dash of x will be less than 0. When it is less than 0, it is strictly decreasing. It is strictly decreasing. It is strictly decreasing. Next, take the second function, minus 2 to minus 1. Minus 2 to minus 1. In between minus 2 and 1, this will be negative always, this will be negative and this will be positive. How means you give a number in between that, children. So minus into minus plus, plus into minus minus. You will take f dash of x is greater than 0. You check it out. Minus into minus plus, plus into plus plus. So f dash of x is greater than 0. It is strictly increasing function. It is strictly increasing function. Next, minus 1 to infinity. Minus 1 to infinity. Between minus 1 to infinity, you take any one number. For example, I will take 1. Minus, this is negative. If I give the positive number, here you will get positive, here also you will get positive. So, for the third term, you will get negative, positive, positive. So it means it is negative. F dash of x is less than 0. Therefore, it is strictly what? Strictly decreasing. It is strictly decreasing function. When it is the decreasing function, we will give the conclusion that since f dash of x is greater than 0, hence f is strictly increasing for minus 2 comma minus 1. Minus 2 comma minus 1. Next, since f dash of x is less than 0, hence f is strictly decreasing for the interval minus infinity to minus 2 union minus 1 to infinity. These are the intervals. Is it clear? I hope you have understood it. So next I will give some more problems. You try it out by yourself. Next problem. This is the homework problem. 10 minus 6x minus 2x square. Take it as homework. You have to find the intervals for which it is strictly increasing and strictly decreasing. And the next one, 6 minus 9x minus x square. These are the homework problems, children. These are the homework problems. Next, we shall move to the next question. I hope you have copied it. Yes. Next, find the values of x in which find the values in which find the values of x, find the values of x in which y is equal to x into x minus 2 the whole square. X into x minus 2 the whole square is an increasing function. Is an increasing function. We have to show that it is an increasing function. Take the function y is equal to x into x minus 2 the whole square. X into x minus 2 whole square. So what will be the dy by dx? 2 into x minus 2. After that, we have to use the product rule. Keep the first function as it is, differentiate the second function, plus now keep the x minus 2 as it is, differentiate the x. So it is equal to 2x into x minus 2 x If you simplify this, plus x minus 2, which is equal to 2x into x minus 2 into 2x minus 2. If you consider f dash of x is equal to 0, you will get that 2x into x minus 2 into 2x minus 2 is equal to 0. You will get x is equal to 0, x minus 2 is equal to 0 means x is equal to 2, 2x minus 2 equals 0 means 2x is equal to 2, x is equal to what? X is equal to 1. So you got the three roots 0, 2 and 1. I hope you have copied it. I hope you have copied it, children. Next you got the three roots, isn't it? 0, 1, 2 plus infinity to minus infinity. You got the three values, that is minus infinity, 0, 1, 2 and plus infinity. We got the four values. We have to check it is increasing for which value. We don't want the negative, we want only the positive. But we have to check for all. So consider the intervals. Let us take we will get the four intervals, isn't it? Next, the intervals, sign of f dash of x, then the nature. Then the nature. You substitute for the f dash. First interval minus infinity comma 0. Minus infinity comma 0. For minus infinity comma 0, we will get the negative. All the three terms are as the negative. Negative into negative, positive. Positive into negative, which is equal to negative. Negative means f dash of x is less than 0. F dash of x is less than 0, which is strictly decreasing function. Strictly decreasing. Next is the 0, 1. Between 0, 1, it will be positive, negative, negative. So positive into negative, negative. Negative into negative, again we will get it as positive, where f dash of x is greater than 0, which is strictly increasing, which is strictly increasing function. Next, 1, 2. In between 1 and 2, if you give the number, it becomes positive, negative, positive. So which will be negative. If it is negative means f dash of x is less than 0, which is strictly decreasing function. Which is strictly decreasing function. Next, 2 to infinity. For 2 to infinity, we will get the positive, all the three terms as positive. So therefore the f dash of x is greater than 0, which is a strictly increasing function. Which is strictly increasing. Then give the conclusion that since f dash of x is greater than 0, for f is strictly increasing for 0, 1 union 2, infinity. It is strictly increasing for these two functions. For the other two terms, it is a decreasing function. Is it clear? For other terms, it is decreasing function. Next, they may ask the question like this. Prove that. Next, they may ask Write down the next question. Prove that the logarithmic logarithmic function is strictly increasing on 0 to infinity.